Error handling is an essential element of robust software. Most programming languages deal with errors by throwing an exception that is caught further up the call stack. Go, on the other hand, does things a little differently. In Go, errors are values. So instead of throwing an exception when something goes wrong, an error is initialized and either handled immediately or returned from the function and handled by the caller. People who are used to the other languages can find this aspect of Go a little unsettling, but let me tell you why I think this is a better way of dealing with errors. Consider this TypeScript code. If something goes wrong, we know it went wrong in the do something function, since it's the only one being wrapped in the try catch block. But what if we had more than one function? Now, if an exception is thrown from either do something or do something else, it will be caught and logged, but we won't know which function encountered the error, preventing us adding useful context to the error message. We could solve this by wrapping each function in its own try-catch block, allowing us to log a different message depending on which function encountered the error, but this has come at the price of code that is more verbose and harder to read. Additionally, the try-catch style of error handling can lead to errors being handled far from where they were generated. Our do something and do something else functions might be calling additional functions which can throw errors of their own. Catching these errors multiple stack frames away from where they were generated is another way we are prevented from adding useful context to the error message. Go's style of error handling is designed to solve these problems. When calling a function in Go, many will return an error as their last result, which can be checked by the caller. If the error is non-nil, this indicates something went wrong, and we can handle this error inside an if statement immediately after the function. This is an example of a design pattern called locality of behaviour, which is the idea that the behaviour of a piece of code should be fully understood just by looking at that piece of code. A link to this can be found in the description. Let's look at an example of error handling in Go. We'll start with our main package boilerplate. Then we'll read the contents of a file. When choosing a name for our error variable, error is idiomatic, but not a hard rule. Since the readFile function is returning an error, we'll want to handle it. We'll add our nil check, log that we've encountered an error and what we're going to do about it, and read the default file we said in our log message. When reading the default file, we assign the error to the blank assignment, that's the underscore, indicating to anybody reading the code that we don't care about its value. We can get away with ignoring the error here because we are confident that the default file will exist. Finally, let's print our content. Before we run this code, we need to create our default file and give it some content. In this example, we've been able to not only catch and handle an error, but we've been able to recover from it without leaving the current function. Each function's error is handled immediately after the function in question, which gives two main benefits. The first is about maintaining the flow of execution through our code. When errors are handled by either logging them as soon as they happen or returning them to the calling function, we maintain control over the flow of execution through our code. When an error occurs in Go, we get to choose what happens next. The other benefit is stylistic. When writing Go code, we separate errors into two types, those we anticipate and those we don't. Those we anticipate are the ones we return, and good Go code is written to handle any error that the developer can anticipate. For example, here are some of the errors anticipated by the OS package that could have occurred when we were reading our files earlier. When we attempted to open the non-existent file, we received an error not exist error. When we're writing packages for use by other developers, we should implement errors to a similar level of detail. The other type of errors are the unanticipated ones. When they occur, the program is said to panic. These can include programmer error, where the programmer hasn't provided valid input to a function, such as providing a nil driver to a database function. Or if a mandatory dependency cannot be satisfied, such as a regular expression not compiling. It's possible to cause your own panic using the panic function, and to recover it using the recover function. Let's look at how that's done. We'll start again with our main package boilerplate. Next, we'll add a function that panics, before finally recovering from the panic in a deferred function. We need to place our recover in a deferred function, because once the program panics, deferred functions are the only ones that are run. If we run this code, we'll see the panic being caught by the deferred function, before control being returned to main to allow the program to finish running. Some are tempted to use this pattern to emulate the try-catch behaviour from other languages. This is inadvisable for two reasons. The first and most important one is that it places error handling far away from the code that generated it, losing the readability and control gained from handling an error returned from a function on the very next line. The second is inefficiency. A panic is intended to cause the entire program to exit, with the whole stack being unwound in search of the source of the panic. Since the program isn't expected to continue running, this isn't intended to be efficient, and that time will add up if you use this technique liberally throughout your code. I'd love to hear from you in the comments if you found this useful. Also, let me know if there's another aspect of Go you'd like to hear about.